Good morning everybody. Today we are going to solve practice problem 3.8 from Alexander Sadiku's Fundamentals of Electric Circuit. So this problem is to be solved by inspection method and to obtain the node voltage equations for the circuit shown in figure. Okay, so the answer is also given. So we have drawn the circuit given in the problem as such, and then we have marked the nodes. Blue color node refers to the reference node or the ground node, and the red colors, they represent the non-reference nodes. So we have four non-reference nodes, so that we can have four voltages, node voltages V1, V2, V3 and V4. And we have to write node voltage equations using inspection method. For this we are going to use this formula GV is equal to I, where G is conductance and V is voltage and I is the current. Already we know that this conductance G is the reciprocal of the resistance. So for the given circuit we have nodes, we have four nodes available, and so we can write the matrix form as GV equal to I. So it is a 4 by 4, okay, conductance matrix multiplied by the node voltages, that will give you the currents I1 to I4. We should also notice that only the diagonal elements of conductance matrix are positive and other triangle elements on both sides are negative. By looking at the circuit given, we can easily form the G matrix 1D at one shot itself. That is, G11 is 1 by 20 plus 1 by 5 plus 1 by 1, and G12 is minus 1 by 5, and G13 is minus 1 by 1, and G14 is 0, and G21 is minus 1 by 5, and G22 is 1 by 5, and G23 is 0, and G24 is 0, and G31 is minus 1 by 1, and G32 is 0, and G33 is 1 by 1 plus 1 by 4, and G34 is 1 by 4 minus 1 by 4, and G41 is 0, G42 is 0, and G43 is minus 1 by 4, and G44 is 1 by 4 plus 1. With this, if you do the calculation, after performing the calculation, this becomes 1.25 minus 0.2 minus 1, 0, minus 0.2, 0.2, 0, 0, minus 1, 0, 1.25 minus 0.25, 0, 0, minus 0.25, 1.25. So we have calculated the G matrix. Now we will see how to form the conductance matrix in detail by considering all the nodes individually. We take only the node 1 and interconnected branches with node 1. The other things we assume that they are not visible for us. So at node 1, using inspection method, we are going to calculate the conductance parameters as well as the current value available. So for this first node, we calculate this G11 as 1 by 20, which is nothing but the conductance available between this ground and the first node, and then plus 1 by 5, which is the conductance parameter between this first node and the second node, and then plus 1 by 1. So it is the conductance parameter between the first node and the third node. Okay. So now we do the calculation for it. So it is equal to 0.05 plus 0.2 plus 1. So it is equal to 1.25. Now we are going to calculate G12. G12 is the conductance parameter which is available between this first node and the second node. So that is equal to minus 1 by 5, which is equal to minus 0.2. Now we calculate G13. It is the conductance between the first node and the third node. So that is equal to minus 1 by 1, which is equal to minus 1. Now if you go for this G14, there is no fourth node being directly connected with the first node. So its value is 0. Then if you consider the current source, no current source is being connected with the first node, so its value 0 amps. To calculate conductance matrix elements related to node 2, we'll separate this node 2 and its related branches alone. So for second node, we are going to calculate this conductance parameters. So G21 is equal to minus 1 by 5, G22 equal to 1 by 5, G23 equal to 0, and G24 is also equal to 0. And the current sources which are connected to the second node are incoming, so it is 3 plus 2, that is equal to 5 amps. So at third node, we have the conductance parameters as G31 is equal to minus 1 by 1, which is equal to minus 1, G32 equal to 0, G33 equal to 1 by 1 plus 1 by 4, that is equal to 1.25, G34 equal to minus 1 by 4, that is equal to 0.25, and I is the leaving current from third node, so that is equal to minus 3 amps. So for fourth node, we have the conductance parameters as below. So G41 is equal to 0, G42 equal to 0, G43 equal to minus 1 by 4, that is equal to minus 0.25. G44 is equal to 1 by 4 plus 1 by 1, that is equal to 1.25. And the current source I equal to 2 amps since it is incoming to the fourth node. Arranging all the G parameters in the matrix form, we get it like this. And if it is simplified, then we'll get the answer as 1.25 minus 0.2 minus 1 0 minus 0.2 0.2 0 0 minus 1 0 1.25 minus 0.25 0 0 minus 0.25 1.25. Now we write the simultaneous equation in matrix form. So it is the conductance matrix multiplied by the node voltages that will give us the current source values. That is 0, 5, minus 3, 2. So we got the answer now. So it's the time to verify our answers with the answer given in the book. Yeah, we got the same answer as given in the book. Thank you.